Alright everyone, so in this video I'm going to go over the Stata practice 3, and in this practice we're using the SAT dataset, and it's very important before you start any of a practice assignment or an exam is to read the description of the dataset, which is available once you click on the quiz. You will find the dataset, the description of the dataset. So the description here of the dataset, you have the SAT. You know what is the SAT? You have a GPA of the student. You have the score of, like a dummy variable for the AP Math Advanced Placement Test. It takes one if the student has taken this test, and zero otherwise. And then you have the AP English in the same definition, one if the student has taken it and zero otherwise. And then you have an AP, which is a combination of the previous two, and again it's a dummy variable. You have the ESL, which it takes again one if the student is the student first language is not English, so he or she is an ESL student. And then we have the next variable is again a dummy variable. It takes one if the student is Asian, and then zero if the student is Caucasian. And then gender takes one if the student is male, and then zero if the student female. And then the last one, which is the SAT preparation course, if the student has taken any or attended the SAT preparation course, and then zero otherwise. So before you start anything, it's very important to read the description of the data set. As you can see, we have just one continuous variable and the rest are dummies, which is, like starting from the AP Math all the way up to the prep, all of these are dummy variables, which is fine. Like it's still our dependent variable is a continuous variable. So in this practice, we are going to so once you open Sakai, and then you click on the practice, the first thing is you have to describe the variables. This is your dependent, and then the rest. Of course, the question doesn't tell you which one is the dependent, but then you can understand that from the beginning of the question. So we're using a cross-sectional data on the SAT score. So it means that our story is about the SAT. Okay, and then we have this SAT score for a certain high school, and then you have the graduating class of about 640. You have 65 who have taken the SAT and were randomly selected. And so our sample is 65 students. It's important to read the description of the data set. And the data set is, you have it in this format, DTA, which is the Stata format, or you have it also in CSV format. So the first question is to describe. We want to know how many integers we have, or how many float variables, how many byte variables, or dummy variables. It's very easy to get this information. You create your do file, and of course you just clear whatever you have, any commands that you had previously in Stata before working on this specific question. So you want to clear any data set that you have. Set more off is a command in order to allow Stata to keep working, not to ask you to click so that you get the next result. So this one makes your life easy if you have a long do file. And then I set my directory, so I just try to make it easier. I put everything on my iCloud. This part would be different from one student to the next, depending on what is your path, where you put your files. So in my case, for example, I put everything on iCloud so that I can access it from any computer I'm using, whether home computer, my laptop, or so it's much easier to put it on iCloud. And it has to be the case that you have enough storage on iCloud. You don't have to put it on iCloud. You can have it on your USB, a flash memory stick, but it's just convenient to have it on iCloud. So this part doesn't have to be the case in yours, depending on your path. And then I start to have a file where I'm going to save all my results, and it keeps replacing every time I'm running the do file, so it keeps replacing the results on the log file. You can consider the log file as your results file, so it will give you like a copy of this do file plus the results in between all of these commands. Use the dataset set DTA. Okay, and then you can also, if you want to use the CSV format, then make sure that you have a different command. It's called in-sheet using sat.csv. All right, so let's start with the first part, which is the description of the dataset. So let me run this one up to the description, and when you check the results, it will give you how many integers, bytes, right? And then how many float variables, and you can just count. So as you can see here, the correct answer is A. We have one integer, which is SAT, we have one float, and we have 5 byte variables. Okay, so the correct answer is A. So it's easy to get this answer by just typing the command describe or D. So it's optional, like Stata would understand if you write just the letter D that you want the describe command. You want to describe your data set. And then put all, if you just write D without listing all the variables, it will give you the description of everything that you have in your data set. If you want to be specific and you choose 2 or 3 or 4 or a couple of variables, then you just list them. Here I just listed everything. Okay, and then the next question is to summarize the data set. So summarizing the data set is the command summary, or you can write it as just here, or you can write it as SU. So SU would give you a summary of this data set. Okay, and when you summarize your data set, you will get this information. How many observations? We said we already have 65 students. So you would expect 65 SATs scores, you would expect 65 AP Math, and so on. So you have 65 observations or 65 students selected. This is the average. This is the standard deviation of each variable. This is the minimum and this is the maximum. So the question is asking you to summarize all of these, and a specific question is what is the maximum and minimum of the SAT score. So all what you need to do is just look at the SAT, look at the first row, and the last two numbers would give you the answer. 590 and then 1430, which is right here, answer number D. Okay? All right, so the next is again straightforward question, is about, so just notice that I keep repeating this part because in the previous version of Sakai, we used to have questions mixed up with different students. So I just wanted not to minimize confusion, so I keep repeating the same question, the head of the question. So it's just important to have just a quick look so that you make sure that we are still using the same data set. We haven't changed it yet. And sometimes I keep changing this part, but in this practice, specific practice, this part just keeps repeating. So that's why I kind of have a space here so you can also read the question or the specific question. So compute the correlation of the variables. So all the variables, we want to compute their correlations. And in here, we have the correlation command, COR, or you can just write correlate. And this one would give you the correlation between the variables. Make sure that I'm just trying to make your life easy. Whatever you have in green here, just under the command is the answer. Okay, so you can look at the answer right here, or you can just look here and, and get the answer. So the correlation between the question is what are the values of the highest two correlations. So when you look here, you're basically looking for the highest two correlations, right? And as you can see, the highest correlation is C, which is this one, these two. Of course, it makes sense. AP is just a combination of AP Math and AP English, so it's actually made out of these two. So you would expect there is a high correlation between AP and AP Math by about 72%. the correlation between AP and AP English is about 77%. Okay, so the answer is not approximated, it's just you will get the answer right here. Okay, so it's again like the first three questions are straightforward questions about summarize, describe, and correlate. Next, we're going to do the main regression model. In this main regression model, I'm asking you to regress the dependent variable SAT on AP Math, AP English, on gender, GPA. And the question is about the statistical significance of the variables. Okay, so when you go here, so we're done with the first three, the main model. When you run this regression, to determine the statistical significance, you can look at t-statistic, you can look at the p-value, or even you can look at the confidence interval. It's like your choice, as long as the question didn't specify. If you look here, you would find that the t-statistic is exceeding all critical values. Under the significance level of 10%, we have a critical value of 1.645. Under the significance level of 5%, we have a critical value of 1.96. And under the significance level of 1%, we have a critical value of 2.58. And as you can see, all the numbers here are exceeding all these numbers, right? All these numbers are exceeding either the 1.645 or the 1.96 or the 2.58, like the last three. So when you look here, this one is significant at the 5%, significant at the 10%, significant at the 1%, significant at the 1%, significant at the 1%. Okay. Also, you can look at the p-value, right? So the p-value would give you the same answer. If this one is significant at the 5%, this one is also significant at the 5%, because you're rejecting the null hypothesis, or the 3.8%, this is 3.8%, is less than the 5%. So it's in the rejection region, right? So you're rejecting the null hypothesis that the AP English coefficient is equal to 0. Okay. This one is significant at the 10%. Why? Because this one only exceeds the critical value of the 1.645. And it is less than 1.96, which is the critical value under the 5%. So if this is significant, so this one is significant at the 10%, or this number is less than 10%. It is more than 5, but less than 10. It is in the rejection region of a 10% significance level. The confidence interval will show you that none of these confidence intervals would have, like, if it is under the 5%, then it's significant under, right, the 1%. So this is significant under the 5%, significant under the 5, under the 5, under the 5. We don't see any 0 in between these two numbers. But of course, there is a 0 between these two numbers, because this is a negative and this is a positive. So the default in Stata is computing the 5% confidence interval. And as I just said, this specific coefficient is only significant at the 10%. So if I'm looking at the 95% confidence interval, I won't find it statistically significant, right? So as long as the question doesn't specify for you a significance level, then you can basically say, like in real life, what you're doing if you're doing research, you're basically looking at any significance level. So just looking at any significance level, I can say that all of these are statistically significant. Nobody cares what level of significance, because the question didn't ask you. And in real life, nobody will ask you. All what you care about is significant or not significant. And we have three options: 5, 10, or 1%. Okay, so the answer here would be C, which is all coefficients are statistically significant. The next, which is estimate the regression model, and then what is the predicted SAT score for a male student. We have already defined the gender coefficient as being equal to 1 if the student is a male student. So whenever the gender coefficient is taking 1, or it appears in my regression model, then it's the equation for a male student. So in other words, we will need to compute, look at this coefficient, which means that the SAT score would increase by about 112 points, right, if the student is male or if the gender is equal to 1. And that's the answer right here. The predicted score is about 112.05. I'm just approximating it. I'm just approximating this number. So it's 11.05 points. Okay. All right, the next question, question number 6, I'm going to take it in the next video.